In the pressure topic, there's only two real bits to it, which is general pressure and then focusing on fluids or liquids and gases for the final equation. So it's a nice, relatively straightforward one. First thing is the idea of pressure. Now pressure is equal to the force per unit area, so force divided by area. What this means is that if you have a small area, say something like a high heel or a pin, and you apply a big force, so a big force on a small area is going to create a lot of pressure. So pressure is kind of an idea of how easy it is for something to pierce something or go into something there. Force is measured in newtons. Area is normally meters squared or centimeters squared. So the units of pressure are newtons per meter squared or newtons per centimeter squared. And this idea was kind of developed by Pascal. So the unit of newton per meter squared is also known as a Pascal. They are the same thing. Pascal is a newton per meter squared. So you can use either unit for pressure. So don't forget that equation. You can see it there. P equals F over A. You need to know that. And you need to know the definition which you can get from that equation. So applying this to different contexts. So I talked about a few there. For example, things with a small area so that we have high pressure would be things like a knife, anything that's used to cut things, so like scissors or a pin or needle. They all have very small areas so that we can create a high pressure and we're likely to cut it. If we have a large area and we're going to have a small pressure, that would be useful, for example, if you didn't want to sink into something. So for example, snowshoes are a great example there because they have a larger area so that your weight is spread out over a large area, so you've got lower pressure and you're less likely to sink into the snow. Camels' feet also similar, they have larger areas so they don't sink into the sand. They've evolved those for that area. So they're good examples and most make sense from there. Tyres of a tractor are also big so they don't sink in the mud. That's pressure, and that equation applies at all times, but now let's focus on liquids especially, or fluids, but liquids especially with this equation here. So for a liquid, in a liquid the pressure is created because of the depth of the liquid above it. If you think about it, if you're down here, all the water molecules from above are coming down and colliding. There's also some colliding from the other side, that's kind of why you feel weightless, but it does apply pressure, and you felt that as you've gone underwater. The equation for pressure, and it's actually a change in pressure because it's the difference in pressure from wherever you start the measurement to wherever you end it, is equal to density of the fluid times by gravity, which is 9.8, times by the depth or the height of water above you. So written out, it's delta P equals rho for density, G for gravity, and then the change in height. So it's only a difference in pressure, it's not the actual value. So say we wanted the pressure at this point here, and this was 10 meters of depth. Well, we could use that to work out the difference in pressure from the top here to the bottom here using this equation here. So you'd use the density of water, which you'd be given, that would be this part here, times it by 9.8, and then times it by the change in height. And that would only give you the difference in pressure from the surface to the bottom. If you wanted the actual pressure at that point, you'd have to add on the pressure pushing down the top, which is atmospheric pressure, and I'd have to give that to you. Remember, that's going to push down on the top, and then you've got all the fluid pushing down, which we've calculated from this. So the total pressure at the bottom would be atmospheric pressure plus by that rho G delta H that you've just calculated, and so that's the key idea there. Now, you might get a question like this, which beaker has the greatest pressure at the bottom? Well, you can now answer that using this equation that we just did for fluid or a liquid. You can see that rho is the density, well that's going to be the same because it's just water. G is 9.8, so that's the same. And actually the height for all of these is the same. So actually you can see the pressure at the bottom for all of these will be the same. It doesn't matter about the shape, pressure will be the same. So sometimes they try to get you on that in the multi-choice. Here's an example of a worked question using that equation again, so you can read it yourself. For calculating the depth, that's the height, h. We know there's a pressure, P, and we know the density, rho, and we know gravity, G. So we have everything we need to use that equation. So as you can see, list out all the quantities that we know. You could just label that in a question. We know we're using this equation here, better written as delta P equals rho G delta H, the delta showing that it's a change. If we rearrange that, we know that H is times rho G, so we divide by rho G to get this equation. Make sure our units are correct. Kilopascals needs to be actual pascals. Remember, Pascal is the same as a Newton per meter squared, so it needs to be in SI units. This is SI units, and this is SI units or standard units. Kilo means 1,000, so we need to deal with that before we use the calculator. Plug the numbers in, so there's our pressure, there's our density of water, and there's our gravity. That gives us a height of 2 meters. So we know that this person or this object is 2 meters below the surface. So we go back to our formula sheet. We can see that we've now done everything. We know the definition of pressure, and we know the equation that works for all situations, solids, liquids, or gases. We talked about some examples, which is relatively straightforward, and then we talked about specifically in liquids, and this equation here, which is one that you need to know and need to remember. Now it's worth heading to the website, which you can get to from here, and having a go at those Google quiz questions. You can pause the video to scan this or screenshot it as you wish. Have a go at the Google form questions and then the written questions on there. Remember to keep evidence for your portfolio. Go well, and I'll see you soon.